So the trig functions are really just telling you a ratio. We want to know the ratio of the opposite side to the hypotenuse side for a 30-degree angle. And so we know that that is 1/2. That's going to be the ratio. So the sine is a function that helps me find the ratio, okay? The inverse sine is the inverse function of sine, which means it's going to start with the ratio and give you the angle. That's all the inverse functions do. So we have been finding the ratios given an angle. We are now going to find the angles given the ratio, okay? And they will give ratios in fraction form usually, so you can put them into your calculator, whatever. There may be times when it's already rounded and you're backing into something and you're going to have to round your decimal place for your degree, whatever. But just understand when they say using the inverse function, all they're really asking for is finding the angle. So if you are presented with a word problem and you are trying to find a side, you're going to use your regular trig function because your side is part of your ratio, okay? It is a length. When you are trying to find an angle, you are going to use an inverse trig function because you are going to be given some information that deals with the ratio and you have to go back to your angle, okay? So you have to recognize, what do I have? What am I trying to find? Do I need just the trig functions or the inverse trig functions to find it? Now, I will say on your calculators, you only have sine, cosine, and tangent. It does not make sense to even need the other three. The other three are reciprocals of those. So if you can find the tangent, you don't need to use the cotangent. Just use the tangent one, right? And so when you're using inverse, the only ones that you will ever use the inverse are the sine, cosine, and tangent. If you look on your calculator above the sine, cosine, and tangent, you're going to see sine to the -1, cosine to the -1, and tangent to the -1. That does not mean they're reciprocal, while it normally would, right? So if I were to say x to the -1, well, that means 1 over x. That's actually the reciprocal. That's not what this means. Sine to the -1 is not cosecant, okay? It just means the inverse function. It's going to reverse the function. So if you hit the sine, you better be putting an angle measure in, all right? Because that's what you're solving for. You're solving for the ratio. If you use the inverse sine, which is above it, you better be solving for an angle because you are telling it the ratio and it's going to assume you're finding an angle, okay? So a couple of things I said when we were talking about ratios. Remember I said that your sine and cosine will never be bigger than 1. Can't be because it's over hypotenuse. And hypotenuse is your longest side. So if you were to take this guy and you were to make sure it's in degrees, which is what we're going to do, and you put in sine of 2, it's going to be like, you're crazy. That does not exist, okay? And you're going to get some error or whatever error message you get on your calculator, okay? So make sure that you if you're given something and you're like, oh, I need to use sine, and it's like 5/4, you did something wrong. You can't use the inverse sine of 5/4. That's not possible. You're telling me the hypotenuse is 4 and the opposite side is 5. That's not possible in a right triangle, okay? And so use the information that you know to be logical about your answers, okay? Inverse sine, inverse cosine, inverse tangent. You're going to use your second or your shift button on your calculator to use those, okay? However you get up to that little piece above that button, whatever it is on yours, that's what we're going to use these, all right? So let's first look at just using it. Example 5, find the missing angle. This clues you in, you're going to use inverse functions here. We're going to use the same process, labeling our triangle exactly like we did when we were just finding a side or just finding a trig ratio. Okay, yes, so 5 is the first one we're doing together. So we have this triangle. Notice where your theta is. So notice which angle you're trying to solve for. I'm solving for the theta, which is right here. So I'm going to label this triangle based on him. All right. So then the 26, well, that is my opposite side, which means the 11 is my adjacent. I do not have the hypotenuse listed, so I'm probably not going to use him in this particular one. I'm going to use the function that deals with opposite and adjacent, which is what? SOHCAHTOA, it's tangent. So the tangent then of theta should equal opposite over adjacent, right? The problem is I'm solving for theta. So I have to use the inverse function. It's just like in solving an equation. If this were multiplication, I would have to divide, which is the inverse function of multiplication. So I have to really do the inverse of both sides. Now there's no need to walk through this and show that you're doing the inverse of both sides. You need to be aware of the fact that you have set it up correctly, that I have the opposite over the adjacent correctly. So to solve for this theta right here, I need to say theta then should equal the inverse tangent of 26 divided by 11. And that's exactly what you're going to do in your calculators, okay? You're going to do the inverse tangent button, open a parentheses, and do 26 divided by 11, close parentheses. You would not want to potentially, this is probably going to be a repeating, you don't want to do 26 divided by 11 and get this repeating decimal, round it, and then plug it in. You want to just put it and round it at the end. Okay, so when you do that, you should get about 67. So when you do this, if you round to one decimal place, you do get 67.1 degrees. All right, so go ahead and do A and B. Round to one decimal place for me, because that's how all of your test and quizzes are going to be. All right, so angle of depression, angle of elevation. All right, depression does not mean you're sad about the word problem. It means you're looking down. So it's always the point of view, which is what right angle trigonometry is always about. However, it is the angle from the horizontal. So keep that in mind. And I say that because the biggest problem people have is saying that this is the angle of depression, and it's not. No. The angle of depression is looking out and down. The angle of elevation is looking out and up. Now, I will say from this guy to the plane and the plane to this guy have the same angles. So the pilot here would have to look down the same degrees to see him as he would have to look up. Now, this makes complete and perfect sense if you remember all your nuances of geometry. We have parallel lines. All right, so this horizontal and this horizontal are parallel. This guy right here is called a transversal. He crosses through the parallels. These then are alternate interior angles, which means they are congruent, okay? So as long as you think about perspective, then I could draw this any way that made more sense. So if I said, this guy is X number of feet away from the tree, the angle of depression from the airplane is this, then what is the actual distance between the two? Let's say I ask that, okay? I can draw the triangle however I want. I could draw a triangle up here, and here would be my right angle. Or I could draw the triangle down here, and that would be my right angle. Whichever makes more sense in your brain to draw it. Now, if I gave this distance here, this is the same distance there. We have drawn a rectangle at this point. If for some reason I needed this distance, it's the same as that distance. And of course, it shares a common side, which is the hypotenuse, okay? So you just have to think about, if they say the horizontal distance, they're really talking about this guy. If they say vertical distance, well, they're talking about this guy. Typically, if they say distance away, they're talking about direct. So it depends in that situation. If they say how far away is he from the plane, they mean this guy right here, okay? Does that make sense? If they say how far away is he from the tree, well, then they're talking about this distance here. So you really have to think about the perspective of the word problem and what you have and what you don't have. What do you need? What are they asking for? So it's just like any other word problem. What do you have? What are they asking? What do I need to get there? A ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights the plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? Okay. So they've given us a little bit of information here. They've drawn it for us. I will not. Okay. All you will have for me is words. Just FYI, I'm not drawing it for you, or that's the same problem as what we just did, okay? So He's 6 feet tall. That's important, okay? They didn't tell us in the words, but they would have to if they didn't give it to us, that this plane is 150 feet in the air, okay? In the air indicates a vertical distance, okay? They specifically say what is the horizontal distance from the worker to the plane. So that means if he were to walk and get directly under the plane, horizontal distance, they are not asking for actual distance because that would be this hypotenuse here. They say the words horizontal, then that's what they're asking for, okay? He is 6 feet tall. This is important because that changes my other side of my triangle, all right? The angle of elevation is from his eyes, we're assuming, okay, which are hopefully at the top of his body, right? So instead of using 150 feet, if I were to go from his eyes across, I'm 6 feet less than what I would be, because 150 is all the way to his feet, right? The angle of elevation is from his eyes. So here I'm actually not going to use 150, I'm going to use 144, because I have to account for the fact that he is 6 feet tall. They did not just randomly give me that information. I mean, sometimes they will to throw you off, but in this case, we actually need it, okay? It is useful information, all right? They want to know the horizontal distance. So they want to know ground-wise, how far away is he from the plane? So then I'm just going to do exactly what I did on the prior problem. What do I have? What do I not have? What am I looking for? Okay. The two sides based on his angle of elevation are going to be my opposite and my adjacent side, right? So which function am I going to use? Tangent. The tangent of 32 should equal the opposite side over the adjacent side. So I'm going to divide here, right? 144 divided by the tangent of 32. They rounded to one decimal place, which was 230.4 feet. Make sure you tell me it's feet. I do need units. The reason I ask you for that is if they had said that he was 3 meters tall and it was 150 feet off, we would need to do some conversions here, right? So you need to make sure, because they will give you something sometimes in different units, and you do need to convert. It has to be in the same units before you do this process. So make sure you put your units there as well. Even without the picture, the lesser of angle of depression is going to be further away from you than the larger angle of elevation there, or depression. All right. So, and opposite if it's elevation, actually. So if this guy's closer, the angle of elevation is actually closer because he had to look up further, right? Because it's closer to him, above him, further away from him. All right. So between the two houses, well, I really just need to find the distance for this house, the distance for that house, and then subtract. They want the distance between the two houses. So I'm doing exactly the same thing. The elevation here is 52. The opposite side is 650. I need the adjacent side to find the horizontal distance from the first house to the balloon. So I'm going to say, well, the tangent of, and what I'm solving for is the x. So actually, it's going to end up being 650 divided by the tangent of 52, right? Remember, if I were to set it up, tangent of 52 should be 650 over x. So 650 divided by tangent minus 650 divided by the tangent of 28, all right? I want the distance between the two. How did I get these? Well, the tangent of 52 should equal 650 over x here. And the tangent of 28 should equal 650 over y here. And I really need x minus y. All right? And so you can actually put this into your calculator without rounding. All right? You can do it all. Just it'll do order of operations if you have a large calculator. If you don't, you may have to put it in and round, and then subtract. Okay? because I want the distance to the first house, that's this guy. So it ends up being 650 over tangent of 52, right? And then I want the whole distance away to this guy, and that's going to be 650 over y is going to be the tangent of the 28. And I want the distance between the two houses, so I have to subtract there. But you can plug it all in and get 714.6 feet when you plug it all in. Solving a right triangle. Solving a right triangle, all they are telling you to do is find every side and every angle. Okay? That's what they're telling you to do. So when I solve a right triangle, here's what I do. I write, okay, I have to find angle X, angle Y, and angle Z. I also must give the side length for XZ, ZY, and YX, okay? I have to list all 6 of those things to solve a triangle, all right? So then I go back and I say, what do I have? I have angle X, that's 35 degrees. I actually have angle Z, that's rather simple, that's 90 degrees, right? How do I know angle Y? Subtract from 180, right? They all add up to 180. And if it's a right triangle, we're going to do solving that are not right triangles. If it's a right triangle, you just say 90 minus the guy, right? So I can immediately get my third angle. That's really easy. My third angle is what, 55? So I can just go ahead and fill him in. They should add up to 180. And then what sides do I have? Well, I have X, Z, all right? And then all I have to do is do my trig functions. To find ZY, all right, to find this guy, I can just use opposite and adjacent, right? The tangent of 35 degrees should equal my X over my 10. And 10 times tangent of 35 is approximately 7.0 when I round. To find Z, well, that's my hypotenuse. So I could use the cosine here, right? The cosine of 35 degrees should be my adjacent over my hypotenuse. And so I'm going to end up dividing 10 divided by cosine of 35, right? Which when I round gives me approximately 12.2. So when you see the term solve the triangle, it really just wants you to find every single side and every single angle using these methods, all right? We are going to move into solving triangles that are not right triangles later on. But these are all right triangles. So you know one is 90. And they may not even give you either of the other two, but they give you two sides that then you can use inverse trig functions to solve one of them. And then again, you can subtract from 180 to get the other guy. Okay? So solving a triangle.